So another technique that we can use for limits is rationalization. So again, we always want to check to see if we can just plug in. But we can see that we have an x in the bottom, so if we plug in 0, I'm going to get a 0 in the denominator, right? And the square root of 0 plus 1 is the square root of 1, which is 1 minus 1, so we get 0. So this is indeterminate. So hopefully you learned in Algebra 2 how to rationalize fractions that have square roots in them. So what we're going to do is we want to try and get rid of the square root issue. So what we're going to do is we're going to multiply by the conjugate. We're going to do that into the numerator and the denominator. So the conjugate, remember, is just the same thing, but you change the sign in the middle. So typically when we rationalize, you're thinking about rationalizing the denominator to get rid of the square roots in the bottom of a fraction, but in this case, we want to get rid of the square root that's in the numerator. So we're going to go ahead and FOIL here. So we're going to keep our limit notation out front while we're working. Okay, so if I FOIL, I get the square root of x plus 1 times the square root of x plus 1, which is going to give me x plus 1. Then I'm going to get positive square root of x plus 1 minus the square root of x plus 1, and then minus 1. And then in the denominator, I'm just going to leave it factored out. I'm not going to bother distributing the x through. And you're going to see why in a second. So, right, the square roots cancel out in the top, and then I have x plus 1 minus 1. So the 1's cancel out. So I'm just going to write this again just to make it a little neater. So when I simplify my like terms in the numerator, I end up with just an x over x times the square root of x plus 1 plus 1. So then my x's are going to cancel out, and I'm going to get the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And now I can go ahead and plug in 0. So if I plug in 0, I can drop my limit notation, and I get 1 over, right, square root of 0 plus 1 plus 1. So that's the square root of 1, which is 1. So overall,